Hello everybody, and thanks for watching my talk. My name is Tobias Drey. I'm from Ulm University and working in the Human-Computer Interaction Group of Professor Enrico Rukzio. I want to present to you investigating the effects of individual spatial abilities on virtual reality object manipulation, and show you in this talk our study results regarding how the individual spatial abilities significantly influence the task performance of object manipulation tasks in virtual reality and our 7 resulting guidelines. Manipulating objects is ubiquitous in virtual reality interactions. It is done by everyone in games for leisure, education and work. Therefore, it must work smoothly for all users to achieve good usability. However, we must consider individual spatial abilities, a capability where individuals differ strongly. Therefore, we expect a highly individual and diverse effect on the task performance and usability of VR object manipulation interaction techniques. Despite these assumed performance effects, for nearly everyone in virtual reality applications using object manipulation, this was never systematically investigated in past research, which we now did with this work. We therefore defined the following research question. Do individuals with higher spatial abilities outperform individuals with lower spatial abilities in VR mid-air object manipulation tasks? To answer our research question, we conducted an experimental comparison of mid-air object manipulation techniques in VR with 66 participants. We correlated the results with their individual spatial abilities by exploratory analyzing several dependent variables. But before I come to that, let me explain how we created an appropriate study design for our research question. As guidance, we followed the checklist for VR object selection and manipulation studies by Bergström et al. Object manipulation can be separated into 3 canonical manipulations: translation, rotation, and scale. You can see in the picture how they are often performed by using gizmos. Each of them can have up to 3 degrees of freedom in our 3-dimensional world, meaning up to 9 degrees of freedom if they are all used in one object manipulation. We focused on interaction techniques applicable to a standard head-mounted display setup based on mid-air controller input to provide generalizable and broadly relevant results. We chose interaction techniques to investigate the whole 1 to 9 degrees of freedom spectrum and selected the previously shown well-established gizmos used in Unity or Blender for simultaneous 1 degree of freedom manipulations as the first interaction technique. You can see in this video how it works. For 3 degrees of freedom, we also selected the gizmos. For both, complex manipulations must be decomposed and performed sequentially when the task needs more manipulations than simultaneously possible with the respective gizmos. We further chose the handlebar metaphor for simultaneous 7 degrees of freedom object manipulation. It can handle all manipulations simultaneously, and participants need no decomposition, even for the most complex task in our study. This resulted in the 3 conditions for the interaction techniques: 1 degree of freedom, 3 degrees of freedom, and 7 degrees of freedom. These techniques provide an increasing complexity. Like the interaction techniques, object manipulation tasks can also be divided into the same 1 to 9 degrees of freedom spectrum. As for many object manipulation studies, we use docking tasks to measure the task performance of the interaction techniques. In a docking task, a source object has to be translated, rotated, and scaled to fit a target object. For example, you can see in the video how the solid source pipe is manipulated to fit the transparent red target pipe. In a Fitts-Law equivalent approach, we measure task completion time and accuracy. Therefore, we present our own Fitts-Law adaptation as nothing suitable for controlling the difficulty of our tasks was defined until now. This was necessary to adjust the difficulty of our docking task, as it is essential for Fitts-Law studies. I will not present the equations in this talk, please find details in our paper. Due to its high level of standardization as well as its generalizability, our study design is a methodological contribution according to rubric and Keynes. It can serve as a template and ease researchers' work in defining and conducting highly standardized object manipulation studies based on docking tasks in a Fitts-Law-like manner. We used the well-established test of Vandenberg and Kruse to measure the spatial abilities of our participants. In this test, participants had to select 2 objects similar to the presented one, but in a rotated view out of 4 possible ones. This means they had to rotate them mentally. The video shows how the boxes can be selected to pick the correct ones. The test shows that the spatial abilities of our participants have a broad range with a peak near the mean. During our statistical analysis, we tested this data and its effects on our dependent variables with multiple linear regressions to save the interval scale of this data. We also conducted a median split to create 2 nearly equally sized groups for additional group comparisons. Summing up our results in an overall manner, please read the paper for all the details. They show that, as assumed, higher spatial abilities significantly improve task completion time and result in more targeted manipulations. We found no effect on task accuracy. Achievable task accuracy is not affected by the spatial abilities. Very important is also our interpretation of the results that an optimized interaction technique can compensate for lower spatial abilities. We saw this in the results of the handlebar, which in our study resulted in the best performance independent of spatial abilities. Based on our findings, we created 7 guidelines. They are split into 4, addressing general interaction technique design and implementation, and 3 for user research. I want to highlight 3 of them. The first guideline states our main finding. The individual spatial abilities should be considered for interaction technique design as users' performance is linked to them. Despite this being seldom done in the past, our finding indicates that this should be done in the future. To emphasize this, I want to show the histogram of our participants' spatial abilities again. You can see how widespread they are. Therefore, we encourage developers to provide support for users with lower spatial abilities. The second guideline puts this further and states that the individual spatial abilities should be measured in applications to adapt interaction techniques appropriately. This can be done by a spatial ability test, like the one we used of Vandenberg and Kuse, but object manipulation performance measures can also be used for that, as our work showed a correlation. And for user studies, we advise. Study results should not always strive to create one result for the whole population, but investigate it in a differentiated way, as the whole population is highly diverse due to multiple individual characteristics. Once again, I want to show you the histogram. You can see how highly diverse a population can be, and it can be challenging to find a generalizable result. However, considering individual characteristics such as spatial abilities can help to interpret the results. Therefore, spatial abilities should be considered for object manipulation studies. Summing up, we have 3 main contributions. First, findings from an exploratory user study regarding the correlations of individual spatial abilities and task completion time and accuracy measured by 11 dependent and 5 control variables. Second, the definition of 7 guidelines on how to consider the individual spatial abilities of participants in VR interaction technique design as well as associated user studies. Third, the definition of a study design template that considers users' individual characteristics for object manipulation interaction technique studies based on dogging tasks, which are defined by formulas derived from Fitts' law. It's a methodological contribution according to Rubric and Keynes. Thank you very much for watching my talk, investigating the effects of individual spatial abilities on virtual reality object manipulation. Please read our paper for further details.